Hey there, Advanced Math. Going to continue simplifying expressions today. Today we're going to do so with the distributive property. Did it work with the commutative property yesterday? Add a new property today. So go ahead and find that next free page in your math notebook. Make this the title of that page. And when you've done so, close your math notebook up. Give me your total concentration until we get to your redo. All right, a couple quick reminders. So this is the kind of problem we did yesterday, and there were 3 steps here. First, we did add the opposite, just so we were less likely to make any careless mistakes from subtraction. So anywhere we saw subtraction, we changed that to add the opposite. So negative 2y plus 6 plus negative 2y squared plus negative 8 plus 5y. And then I use these tiles to show what this looked like. So like negative 2y, I only have x's on my tiles, negative 2y plus 6. This step's really optional, the drawing. If you get to where you can do these without the drawing, it's fine. I like to do it, just kind of remind you how it works though. Negative 2y squared minus 8. So this was, remember, the x's and x squareds were different. 8, was it negative 8 or 8? Can't remember. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then my last term was 5y. Whoops. Eclipse photo. 1, 2, 3, 4, and 5. So that was how I set it up. This is what it looks like. And then the next thing I wanted to do was put stuff that goes together. So like I wanted to move the x's all together, the like terms, the x squareds all together, and the numbers all together. And I can do that no problem because of the commutative property of addition. So what I really do is I moved them around so that the y squareds were together. Then the numbers were together, so the 6 and the negative 8. And then the y's were together over here. Did I do 6 instead of 5? No, 5, good. Plus 5y plus negative 2y. So commutative property was 2, and with that I just lets me put things together that go together. The math term for that is like terms. So these were like terms, and these were like terms. And then the last thing I did after I had my like terms was combine like terms. So this didn't have any like terms, the negative 2y squared. The 6 and the negative 8, you know how to add those. You know, I have the pieces. I could do it with the pieces. You're probably good at this point. Adding 6 plus 8 is negative 2. And 5y plus negative 2y, same way. I'm going to have 2 zeros, and I'd have 3y. So it's almost just like the variable is not there. And of course my negative 2y squared that I ran out of space to write. And so that was a simplified version of my original expression. The other thing I want to review is the distributive property. Been a long time since we talked about it. When you see a product of a sum like this, that means I can rewrite that as 5 times negative 6 plus 5 times 3. Those would be the same thing. That's the distributive property. I multiply that outside term by both terms on the inside. Okay, that's how the distributive property works. And so we're going to work on simplifying expressions today that have an opportunity for the distributive property in them. This is 2 times both of these, 2 times 3a minus 2. I'm going to show you how that looks and show you how it works. So first thing I'm going to do, I want to simplify this. Simplify. And same thing, I'm going to start with add the opposite. It's really tough to do these if you don't reset them with add the opposite. So I have two subtractions here. I'm going to change those to additions and keep everything else the same. 3a plus negative 2 plus negative 8. All right, so here's my chance for the distributive property here. So the next thing I'm going to do is my distributive property. So what this looks like, I have 3a plus negative 2, if I reset my tiles. So 1, 2, 3a plus negative 2. So I have what's in the parentheses, and I have it all 2 times, 2 sets of this. So I have it there once, and I have it again. Right? And so what you can see now is that really what I have is 6x and negative 4. Or I think they're a's. So what this ends up being is 6a and negative 4. If I do my distributive property correctly. And that works. You can see here, 2 times 3a is going to be the 6a, and 2 times the negative 2 is going to be the negative 4. So you can do it without the drawing if you want. I like how this shows what it looks like and why it's the same as this, but you can also just do the math and know that it's that too. A lot of times these drawings, I just think it makes it clear, but you don't have to. So now I've done my distributive property. Don't forget this. I still had this negative 8 off to the side. And now I can just combine like terms and I'll be done. So these can be combined. Negative 4 plus negative 8. Those are like terms. And so those will be negative 12 when I add them together plus 6a. So this is a much simpler version of this expression. These are equivalent. I'm not going to do it, but whatever you chose for a to be, 1, 2, 10, negative 4.5, whatever you put a in and see what all this equals, it would be the same down here, but much simpler, much simpler to do. Okay, open your math notebook up. Let's do one together. So I'm going to show you the drawing of this. Again, if you like the drawings and you want to do the drawings, that's great. If you don't like the drawings and you just want to do the math, I'm okay either way. I like you to have the drawings as a backup if you need them to, if that makes more sense. So first step, we're going to simplify that. I didn't write simplify. So we're going to add the opposite first. This is always a good start. That way you don't accidentally make that mistake. So I only have one subtraction here. And everything else stays the same. 3 times negative 2a plus negative 4 plus 5a. All right, so if you want to see what that looks like, it's negative 2a plus negative 4, which looks like, come on, this, negative 2a plus negative 4. And that's what's in the parentheses. So I have this 3 times. I have like 3 sets of it. So 1, 2, 3. And so all in all, I have 1, 2, 3, 4, 5, 6. So I have negative 6a. And you can see 3 times negative 2 would give you negative 6a. You can do it from the math, or you can kind of see why. And then I'd have 4, 8, 12 negative 1s. So plus negative 12. And that's really 3 times negative 2a, and then 3 times negative 4. I like to see it. If you don't need to see it, you don't have to do the drawing part. And so now that's my distributive property. And then I'm going to add to that 5a. that's still there. And the last thing I have to do is combine like terms. I have a few. So my like terms are going to be the negative 6a and the 5. If you want to do the commutative property first to put them together, you can. Or you can just combine them straight from here, either way. Commutative properties, why you can. Negative 6a and 5a is going to be negative 1a and negative 12. And again, if you needed to do the drawing, you could do the drawing, because I have over here, I could add my 5a to my drawing. I didn't do that. And then when I combine, I'll have a 0, a 0, a 0, a 0, a 0, and then one more negative a. So negative 1a after I combine these and these, and the negative 12. That's how you do it. So not too bad with the distributive property. We actually use the commutative property too. So that's how you simplify an expression that has a variable and a opportunity for the distributive property. So that was only 2 examples. I've been doing more than 2 examples pretty often. If you feel like you're pretty clear after watching this and how this works, great. If not, please go back and watch this again. These are just going to get increasingly more complicated, so please make sure you keep up. All right, guys, see you tomorrow.